Hello, welcome back. We are here with episode 3 of Database Deep Dive. They have not canceled us yet. So, Randall and I are back, your favorite co-hosts, and we have with us a special guest. Who are you?
Hi, I'm Yoav Eilat. I am a product manager for Amazon Aurora, which is another database from AWS. I'm really excited to be talking about it today.
Wonderful. So last week we were living in the world of NoSQL, talking a little bit about DynamoDB with Rick. But let's flip it to the other side now. We're talking about Aurora, relational databases.
Yeah.
Where do we start here?
Okay, so I think what helps to understand this is to go back to our first episode where we talked about the evolution of databases. And you go back to the 1970s and the 1980s, and you have storage being the most expensive part of your data story. You end up optimizing your data model around storage. And this is great for a lot of different use cases. It allows for very efficient queries and very efficient storage of different types of data. But then as scale grew, as people went from millions of users to tens of millions of users, or in cases like Duolingo, they have 300 million users, and they're using DynamoDB. As people scaled out to lots and lots and lots of different users and lots of different use cases, that model starts to break down because you're limited in the number of nodes that can simultaneously access and transact on those pieces of information. So what I like about relational databases is that it's a very good way. Apparently I'm barely audible. What I like about relational databases is it's a very good way to access the underlying normal form of the data, the third normal form. So if you want to go ahead and get your background in databases, go Google third normal form and read 6 hours of that, and you'll know just as much as we do, which is not hard.
Well, so before we even dig into access patterns and querying, relational databases for most people are the way that they sort of normally think about data, right? Like a lot of people, before you learn about all these different tools at your disposal, you think about things in columns, you think about things in rows, and so even though other databases may be permutations on that for optimized for different use cases, people still have a hard time breaking out of this relational shell, but for good reason, right?
Yeah.
A lot of data fits very well into the relational model.
You reach those thresholds that I was talking about, and one of the things that I love about Aurora is it says, hey, it's 2019, or when was it? 2015? 2014. Hey, it's 2014. We have all this modern technology available. Why don't we reimagine databases in the cloud? So maybe this is a great point for you to kind of tell us more about it and how it works and all the magic behind it.
Sure. Yeah, so relational databases are still really important. It's still where a very large percentage of the world's data still lives. They've been around for 40, 50 years. And it's really good that today you have other options. So for data that doesn't fit very well, for objects, for key value, for certain things, it's really good that there's other options. Some people continue to put them into relational databases just out of habit, and that's fine too. So it's good to have those other options, but still there are many, many, many cases where the data does fit fairly well into tables, rows, columns. There's complex queries that you want to run. Relational databases are still very good at doing that. And the SQL language is still as relevant as ever. It's even being used for non-relational databases because it's kind of, it's the standard.
It's what people know.
It's what people know, and it's very powerful, and it's an industry standard. So it's still very important. And like you said, getting into, this decade, it was time to start rethinking the way that relational databases were always built. And like you said, one of the assumptions was storage is expensive. But looking at today's world, storage is kind of cheap. So if we make that assumption, how can we build a database that will be more durable? Will store your data maybe in more copies, because if storage is cheap, hey, let's back it up like crazy because we can afford to do that.
Yeah, so that's a great point. So we looked at these bindings and interfaces for querying data in a relational world that people love, MySQL or Postgres, for example. But what are the real innovations around Aurora, and how do they leverage those things that people already loved, but then on the operations side make it a more valuable product?
Right. So the problem, like almost anything at Amazon, it starts from the customer and works backwards. So we asked ourselves, we meaning it was even before my time, or I guess any of the three of us, but a few years back, the question was, what do people like and dislike about databases that are available on the market? Databases and the vendors that provide those databases gained kind of a reputation for being expensive and being very restrictive. And AWS wanted to kind of provide a better option that would be much cheaper and would be much easier and open and flexible, be based on open source, which is...
We'd rather pay engineers than lawyers.
Exactly. And auditors. And yeah.
So yeah, that was released a long time ago, and we joked
Right.
that it was probably before all of us, but I think, Randall, you were actually around.
maybe
when that
Randall.
I
happened,
was
right?
around.
With the
yeah.
exception of Randall.
We have the dinosaur over here.
Exactly.
The cool thing that I think just kind of blew my mind, and I in hindsight, it's obvious, right? That
Right.
all the best discoveries are is when we control that whole platform. So we meaning AWS, we have this whole control plane, and we can say, well, we know exactly what kind of semantics and what kind of pieces of hardware are going to be running
Yes.
in this control plane. Why don't we optimize and specialize an engine for that? And it was this realization that we could separate that compute tier from the storage tier and just blow that out as much as we needed to in order to make the database scale to whatever kind of workload it needed to.
Correct. So Aurora, and that's a good. This is a good point to point out. Aurora is a database engine that runs under Amazon RDS, Relational Database Service. So RDS itself is a managed service where your database is managed for you. You don't need to do any backups. You don't need to do any patching. You don't need to set up and provision the hardware, any of that. So running Aurora inside of a managed service, like any managed service, it comes with certain trade-offs, right? So on one hand, you don't need to do any work, any of that work. It kind of does all the or almost all the administration for you, at least in terms of hardware, operating systems, VMs, all patches, all of that. It comes with certain restrictions that you don't just get root access and do whatever you want, because in order to run a service at high scale like we're doing, you need to make certain assumptions that people are not messing too much with. We need to standardize all those instances to make sure that they're all the same, and then we know that our patches will actually work. So Aurora runs under that environment. We know what the hardware is, we know what the operating system, we know all of that.
And I remember working on databases back in 2010 with the kind of the CC1s. Maybe it was earlier than that even. The first version of EC2, and we started. I think this is before RDS even came around. RDS came out in what, like 2011?
RDS was 2009, I believe.
2009. Oh, well,
Yeah.
RDS was already around, but the place that I was working at, we weren't using it yet, and I remember having to tinker with read ahead settings and
Yes.
mounting the volumes with no A time and mounting the volumes so that the underlying storage section could be shared across multiple nodes with this insane NFS setup and
Exactly.
all people did this just to run WordPress at scale.
Yes. So nobody wants to do that anymore. So RDS grew into a family of multiple database engines that are offered. There's 6 or 7 depending on how you count. And Aurora is kind of the crown jewel, and let's get into more details on that, on what we did in terms of changing the engine. So the engine, building a database in a sort of more modern way that makes all of those assumptions about, about storage, about network, about all of those things. So some of the first things that were, the first design principles is we wanted it to be compatible with open source. So instead of, and I'm sure that the people who were there at the time debated this, the pros and cons, if we started from scratch. I'm sure we could have changed a few things, maybe, had some advantages, but they were
SQL compatible.
exactly. But
So there's an inside joke that I will explain to anybody who ever meets me in person.
so did not go in that direction, and thankfully Aura started out as a completely MySQL compatible database, where basically we took the MySQL source code. First of all, made a few changes in the storage layer in order to make it much more available, much more durable. We'll talk about that. Plus a few extra features that are at the database instance, like in the database executable itself. So you get a lot of advantages. And then a few years later, we added Postgres. So now you have a MySQL and Postgres compatible database. It's a complete drop-in replacement, which means that you will not have to ever change a single line of code in your application, switching back and forth between Aura and the open source MySQL and Postgres. So you can move back and forth. If portability is a concern to anyone, you can write it on Aurora. You can take the same application, run it in a different cloud or on premises, and you don't need to change any code.
Yeah. So Richard Boyd from Twitch wants to know, how do I get billed for Aurora usage? What's the pricing model?
So Aurora is billed with a number of items. One is the database instance or the compute layer that's running. You pay for that hourly. There's discounts if you sign up for a long-term plan.
Reserved instance.
A reserved instance. In addition to that, you pay for storage. So whatever your database creates, you pay for that. Plus a few networking and I/O. There's I/O charges. There's a few special items, that, like a few special features, which are separately priced. So that's all on the
performance
insights.
and
Most people don't pay anything, only if you want to keep it for 2 years. Backtrack. So there's a few special items like that, but for the simple answer is you pay for the running instance and you pay for the storage that you're using.
Great. So that's actually an awesome segue, because there are a lot of things that make managing your own service or being your own database administrator difficult.
Right.
One of the things that you touched on was scaling and separating compute and storage. So this is one of the bread and butter value propositions of Aurora. How does that happen, and how do users have to think about scaling of storage and compute when they're using it?
Right. So let's start with compute, perhaps. So with compute, the standard thing, you launch a database, you have one instance, one server running it. With Aurora, you can go and you can say, I want to create additional read replicas or read nodes, which increase your read scalability. So given that it's a cloud, given that we know the environment, it's very easy for us to go and just create another read replica. You can do that across 3 availability zones, like pretty much any AWS service. So we have that advantage. That's actually the smart thing to do, is if you're going to run 3, like one master, one primary instance and 2 read replicas, put them in the 2 other availability zones. That would make more sense. And you could put them in other regions. So a feature called Global Database, which was announced at reInvent in 2018, allows you to replicate to another region. And I need to mention that each database can have up to 15 read replicas, and the same in the other regions. So you can have a database with 15 replicas, copy it into another region where there is another 16, and so on. Every other region has another up to 16 read replicas. So given that it's cloud, it's very easy for us to just go and do that. You just check a few boxes. Now your database is running across the world. We have some customer examples. Intuit was a really good example. So they're one of our references for this feature. So they put classic thing, you put one on the West Coast, one on the East Coast, and now people in each region get very fast local access. And if there's a disaster, then for disaster recovery purposes, one goes down, the other one is a tiny bit behind. It's like less than a second, and then you can continue working from the other region.
Great. That really falls a lot under like the scaling out concept, right? But as for scaling up, typically you see for databases certain tiers, right? It's like what speed do you want for network bandwidth, so on and so forth.
Right.
And predicting when you need to make that jump to a larger storage a unit. But Aurora doesn't have that, right? It will scale dynamically to whatever data you have, not just charge you for that, but you don't have to worry about flipping the switch to provision a larger instance, right?
Correct. So yes, so Aurora on the storage level, it's completely auto-scaling. So what it does is it allocates the storage in 10 gigabyte chunks. And every time you need more storage, it just allocates the next chunk, and you pay for exactly what you use. So you don't really need to think about it. You just write to your database, and it kind of takes care of itself. Up to, so right now we have a limit of 64 terabytes, good enough for pretty much any purpose. I've never created I don't think I've ever created a 1 terabyte database.
Challenge accepted.
Yeah, you can do that with 1 line of code, I know. So yeah, and going back to the compute layer, you can also scale up on the compute layer onto some pretty, big beefy instances. So with multiple cores, and it's maybe considered a little old-fashioned these days. I mean, back in the 90s, I think the way to scale your application is to put a bigger and bigger database as you add users, and applications were kind of built that way. And inevitably, you get into these monster hardware for your database when your application is written that way. Today in the cloud, you can scale out, you can create replicas, you can you can write your application in a more, kind of easier to scale way. That's how web applications get built. They wouldn't get built by, putting a faster and faster CPU, to put all of Amazon.com on one CPU. That's not going to work. So modern applications are obviously built with scale out in mind and regional expansion in mind.
Modern day problems require modern solutions, right?
That's my tagline, so if you hear me say that too many times, I'm sorry. So I think it's Thelior is asking about running Aurora in a Docker instance. The good news about that is that you don't need to, because it's just SQL or Postgres. So it's really just, regular. You can run MySQL in a Docker instance, or you could run Postgres in a Docker instance, and then you would be able to use the exact same commands and queries to access the Aurora database in prod.
Correct. Yeah, there's some, I guess, best practices, which we can point to some documents that we have around how you would do that. Like if you have multiple Docker containers and you're accessing the same database, and like exactly how that would work, which goes, deeper than I guess we want to cover today. But the database itself, I mean, it's just, it's an endpoint to you. It's, you just access it. There's also a preview of HTTP access to the database, which might be useful with Data API, which might be useful to some people. Like if you have many clients kind of with short-lived connections, like from IoT devices, which is the classic use case, then you can just connect. Those may be running in containers or maybe running I don't know where, and they can just connect through HTTP.
So what a lot of people don't realize is when they are accessing MySQL or Postgres, the ORM or the client that they're using to connect in their code is responsible for a couple of different things, right? It's doing connection pooling, it is doing retries and maintaining state, maintaining session, session variables that you set for different transactions and timeouts and all of those things. That client is responsible for setting all of that state. And it's typically abstracted away from the code that you really write.
Yep.
But the cool thing about the data API is your SQL kind of query is transformed into an HTTP request.
Yes.
And the other advantage of that is if you go into an environment with like Lambda functions, you don't have to run a PG bounce, which would be a common method for pooling different connections together. You don't have to run PG bounce on some Fargate container out in the cloud somewhere. You can just go and say, I'm gonna, hammer this instance with lots and lots of connections, and it handles the connection pooling on that data API side.
Exactly.
It's very powerful. And then there was another question from Thelior about the local development and the Docker side of things. And the other thing that I'll point out is one of the advantages of Aurora is previously, if you wanted to spin up a dev instance, right, of your production workload, to do that would take time, because you would have to say, if you had couple terabytes worth of data, it would take time to go and get into the dev VPC, and then you'd have to have it, restored from the snapshot, and it would take hours and hours. Snapshots in Aurora are like minutes.
Correct.
It's straight dope. It's super cool. You have no idea how much time in my life has been spent on the CLI lazily looking at how far along that rsync command is, and to not have to do that.
Yes.
Very technical term, straight dope, right?
Yeah.
That's highest praise we can give it. But
It's an extremely technical term.
Yeah, we actually had some other awesome questions on the concept of scaling before we move on. So Richard asked, with respects to the multi-region replication, does the service charge for network out fees on the data, or is it just the as per the line items that you listed before for storage and compute?
It does, yes. So when you use that feature called global database, you're basically paying for the databases that you are running in whatever region they're running, and you're paying for the data transfer between those regions.
Okay,
that's correct.
And just a correction from earlier, we actually bill per second now.
We do bill per second. Yeah, that's very new. So
if you're keeping your database up for
1 second,
No,
I think there's a 10-minute
there's a 10-minute minimum, right?
Yes, so if you're keeping it for 10 minutes, you gain those 50 minutes.
Yeah.
You can feel good about yourself. Yeah,
it's good.
And this is we talk about auto-scaling a lot across a lot of different services, but in relation to it auto-scaling to more data that you put into it, does it automatically scale back down, or do you just not even need to worry about the ops under the hood? You just worry about the fact that your data lives in that database.
Right. So let's talk a little bit about autoscaling. So there's basically two types of autoscaling in Aurora. One which is scaling in and out, and the other one is up and down. So starting with in and out, it's based on the autoscaling capability that's built into EC2 and a bunch of other AWS services, where there is basically a set of rules, and if certain thresholds are met, it'll start another replica, and then it'll shut it down when it falls below that minimum. So Aurora supports that, and you can scale out that way. So that's one. The second thing, which is kind of more fun, according to most people, is what's called Aurora Serverless, which makes the database serverless in the same way that a lot of things are serverless, like Lambda, like others. So if your application layer is serverless, and that's the way you write it, how about if your database layer was also serverless? I think that's a good match. So in a serverless database, you never think about the hardware. You don't know how much memory it has. You don't know any of that. You just say, I need a database, and it's measured in units, which we call the Aurora capacity units. And you start with, maybe one of those or two of those. You know how much they cost. And if the load on your database grows, it will move your database. It'll scale it up to a bigger instance size. So, bigger CPU, more memory, whatever you need. And it can scale up multiple times, or it can scale down even all the way to 0. So if you want, you can configure it that way. If there's no traffic on the database at all, then after a certain amount of time, it'll shut it down completely. At that point, you'll pay exactly 0 until traffic starts up again, and then within a few seconds, it'll go back. So for some people, that's not acceptable. They don't want the first user that comes along after the break to have to wait for 10 or 20 or 30 seconds. If that's acceptable to you, you can save money that way.
It's amazing for dev workloads to be able to go down to 0, right?
Yeah.
I mean, I went in and I took snapshots and I restored into these Aurora serverless clusters for pretty much every production application that I run, because a lot of them, don't get that many hits unless I'm actually out there in the field demoing it. Yep. And so I have it scaled down to 0. And then right before I go on stage, I do one little refresh request, and then it's golden for the next 30 minutes as I'm demonstrating it.
Yeah.
And I feel like this is just one of the biggest pain points in general about pay per unit of time, services, right? It's like you forget you left it on, or you don't want to have to then inherit the workload of spinning something up and tearing it down every single time you just want to show somebody, right? So this gives you that flexibility, but also only charging you for exactly what you're using.
Yeah, I mean, it's good for different types of scenarios. So one is if the load is unpredictable. So if you have some of the examples we usually give are blogs or newspaper sites or things like that, where suddenly if there's a big breaking news item, now suddenly 1 million people, jump on your website, and you can't predict that ahead of time. Yeah. And that's how you would deal with the unpredictable situation. Another one, going back to what Randall, like what you said earlier, you spend all that time spinning up databases for dev test, and if you could get back that time. So here, this one surprised me. I have to say I was wrong about this one, because I thought that it was kind of stupid to use serverless for dev test, because you're too lazy to shut down your QA instances at the end of the day. I mean, come on, you just go and
you don't know how many demos Randall
It's totally
builds.
predictable. It's not you. I mean, it's totally predictable. But even so, being able to walk in there and click and not have to wait for the whole thing to come up, that's the point for developers and testers. That's a lot of time savings. So it's not
right, because you're not having to worry about if we want to go a little bit deeper,
this is database deep dive. There's nowhere else to go any deeper.
So Aurora even takes care of the cache files, the page files, and there's a whole layer there, and you can read about this in the Aurora paper. So there are a couple different Aurora papers now, but we publish, I think, 3 now.
I think 3 or 4. Yeah.
3 or 4 now, different papers on the architecture of Aurora and the learnings that we've had. I think the first one came out in 2015, and then all the subsequent ones have been iterations on that, and we're trying to open up about the realizations that we've had at running these workloads at scale. And I kind of forgot where I'm going, but the fact that even your snapshot layer is like a direct restore or fork or a pointer to the new data that you're trying to access. So instead of you having to wait for this compute layer to what's the word that people use when it has to, it's like the same word that people use for water instead of,
to dehydrate.
Instead of hydrating these compute nodes with all the data. Sorry, brain messed up today. Instead of hydrating these nodes, they're just pointing at the storage that already exists.
Yes.
And I'm forking off in another direction from the storage, and it's like
I know.
it's instant. It's so
And
crazy.
there's a little fleet of instances or like proxies sitting there waiting because the application doesn't need to know that the database went down. It needs to keep to see the connection still there. So that fleet is waiting there at our expense. And if there's a new read or write, then it'll actually start up an actual instance from the pool of databases that it has there. So yeah, it's pretty cool. So let's also talk a little bit about how that works on the storage layer.
Yeah.
So
I'd love
there, let me mention two features. One which is called fast database cloning, and the other which is called backtrack. Which is kind of related to the type of problem that you were talking about, where you want to just have a copy, you restore from a snapshot. So with fast database cloning, you actually create a clone of your database without using any storage.
Right.
Because all it does, and there's similar features in usually storage systems, things like that, where you can create a clone, and now you can give people as many copies as they want because each of them has, just the clone doesn't actually use any storage, doesn't consume any storage unless they write something.
Yeah.
Unless there's a diff, and the diff means that they write something. So, so that's one thing. That's one way to quickly create a database for your development. So that's called fast database cloning, available in both Aurora, MySQL, and Postgres. Backtrack is a way to restore your database to a previous point in time. So you can define a window based on basically how much you want to keep. How much history you want to keep.
Does that window start at 7 days, or does it
Starts at 72 hours, I believe, is the default.
Okay.
And
So even without opting in, you already have sort of that protection for 3 days, or
I think you have to turn it on.
You
you have to turn it on, and you have to
Backtrack,
pay
but
for
like-
the storage.
Okay.
So if you want us
Yeah.
to keep that, you keep as much as you want, but that's
Yeah.
you're paying for that storage.
Exactly.
So that's pretty cool. If you make a mistake, you can just roll back, and given the way that the Aurora storage system works, we haven't actually talked about the architecture, but you can move back to that point in time within seconds. It doesn't need to restore from a backup. It's just a storage layer operation in Aurora. So either it's good for recovering from mistakes, or another nice use case for backtracking is for QA. So imagine that you have a test case which is destructive to the data. So one of the examples I like to give is, let's say that you're an e-commerce. I don't know why I thought of that example. Let's say that you're an e-commerce company, and you're testing a test case where you're taking the last item out of inventory. You want to see how your application deals with that. So you run your test, you take the last item, everything works fine. Now let's say you make some code changes, you want to test it again. You can't, because you just took the last item out of inventory. There's the data you don't have. So what you can do is just use backtrack. Just move it back a few minutes before, and now you're ready for the next test run. So you just put that in your test script, and then what it'll do. It'll backtrack. Now you have the item back, run the test, and every time the item comes back. So I think for QA it would be pretty useful.
And I like that the underlying storage layer, one of the things I guess we realized is we can break the data into all these smaller chunks and then move those smaller chunks around and kind of replicate it in multiple availability zones.
Correct.
Have we ever had like an entire AZ go dark?
Not that I recall.
I've been doing this for a long time. I've never seen that. But even if we did have like one entire AZ just drop off the face of the internet,
Right.
You still have 2 other AZs at least where that data is replicated.
Correct.
And within a given availability zone, we take a lot of measures to make sure that is durable, for lack of a better word, right? Like
Right.
An availability zone consists of having multiple geographically separated data centers, such that if the power goes down at one of them,
Or natural disaster.
yeah, exactly, that they're physically separated,
Right.
to prevent that from necessarily taking an entire availability zone down.
They're far enough away from each other so that if there's a disaster in one, it's not likely that it'll be on in the others. But they're close enough so that the latency is low, so that we can send data very.
We can push the boundaries of the laws of physics.
Exactly.
And an AZ
So-
has 3 separate data centers typically, right?
Correct.
Or
And an AZ has.
Multiple.
Well-
The line that I guess we hear from Peter DeSantis or James Hamilton and those folks is that AZs are typically comprised of multiple data centers. And then they're connected with if we scale out US East 1, for instance, you go and you look at 1A, one building, it can have as many as 6 different buildings, and then between those buildings you have 2-inch metro fiber connecting them with or 2-inch conduit full of like 6,912 fiber pairs, and then The trucks that they use to splice these fibers are totally crazy, by the way. Because you need a literal truck, like an 18-wheeler, to go and like fix these. And then they have, in US East 1A, I'm saying 1A, but 1A is not the same for everyone. But they're internal descriptors that say what these are. We have as many as 384 unique fiber paths through those different buildings, which is
How many?
384.
No way.
All right, it sounds like we need another show.
Yeah, just on that.
Diving deep on cable technology.
I spent some time in Australia and Sydney with our networking team there, and the things they have told me about our cabling and the stuff that we do is just phenomenal. Like, we built a special coating for Australia because the termites there evolved to eat plastic. Like, it's crazy stuff. And
Modern problems, modern solutions, right?
Here's the thing, right?
Right.
Is Aurora wouldn't be able to exist if we weren't innovating at every single layer of the stack. So you can't just invent some amazing new piece of software. You actually need people who are going to be able to go through that whole stack of problems and solutions and attack each one and try and innovate on each one. And that's what's kind of unique about Amazon. I've worked at other places and they kind of offload some of that innovation effort to suppliers and stuff like that. But here, it's like, hey, let me invest as much time and effort into finding a better solution. And we make no assumptions about the past.
And it's available to anyone. I mean, if you thought about like 10, 20 years ago, if you started a company and having a copy of your data on the West Coast and on the East Coast and in Sydney, that would have been unthinkable.
Yeah, no, it's 10 years ago. It's pretty interesting.
Yeah.
There's we have a lot of questions. We're gonna have a hard stop here at 1 p.m.
Yeah.
So maybe we should just show launching an Aurora cluster for a second and kind of go through that. Can we get the computer? This computer. There.
Wonderful.
Okay, great. So I am looking at the AWS console or the RDS console specifically. Here you can see a list of my databases. I don't have any running right now. Let me go and create a database, and I won't do the whole process, but let's just show a few things that are interesting, that some of what we talked about today. So first of all, as we said in Amazon RDS or Relational Database Service, you need to choose which engine you want to run. So I will choose Amazon Aurora, which is the first one. You can see that there's other popular databases available here. One of the first questions that I will want to answer is, do I want it to be MySQL or Postgres compatible? So these are two editions of the Aurora database, and which version of those database engines I want to use. So 5.6 is a standard MySQL version, and there's other ones. There's 5.7 and other options. We talked about regional. So when I choose about global database, so when I choose to run my database in just one region, that's the simplest option. I choose one AWS region, and that's where it runs. Or I can say I want global database, which means I can choose other places that it'll get copied to. A few other things that you can choose, aside from the default option where you have a primary instance and multiple readers or read replicas, up to 15 read replicas. You can also use what's called parallel query, which is an option that we didn't talk about today, but it's basically, going back to what Randall, that you said, that we have a powerful storage layer where we spread out the data across hundreds of nodes, and they're all basically, like storage nodes that are doing the work of, storing and reading and writing your data. Why not also put them to work on your query? So since we have all that compute power,
like
it's also like MapReduce. You have these hundreds of nodes, and each one of them holds a little piece of your data. Now, if you're doing a big, full table scan, not that you should do that every day, but let's say that that's what you're doing, then each of them can look at the data that's on that local disk on that node, do some pre-processing. It doesn't know everything about your query, but it can do some of that. Send a much smaller amount of data to the head node, and then the database instance, compute instance, will actually do the rest of the work. So that's called parallel query, basically putting these to work on your query.
This is a question for me, and we have a bunch of questions from the stream that we're going to get to. But do we have parallel query in Postgres as well?
Not yet.
Not yet. Okay.
This is, you'll notice that I selected the MySQL option. And let me just answer that question in a general way, which is the MySQL edition of Aurora came out more than 4 years ago. Postgres came out less than 2 years ago, end of 2017. So, there was a 2.5 year gap. It's shrinking. I mean, we're adding features to Postgres all the time. It's still, I wouldn't say it's 2 years behind, but it's still more, it's still behind in terms of some of these features.
I'm looking forward to more Postgres stuff. I mean, I love Postgres, I love MySQL,
Yeah.
but Postgres is where
Okay.
it's my favorite. So
So you'll be happy to hear that serverless, which is an option available for MySQL, is coming out pretty soon for Postgres as well. It's been in preview for a few months now, and the release is getting very near. So serverless is what we mentioned earlier, where it'll scale up and down your database. Okay, so these are kind of the main. I'm trying to think if there's any other.
well, we were talking about we were talking about autoscaling, and one of the interesting things about scaling Aurora and RDS is we released a service a couple years ago called application autoscaling. So within EC2 you have autoscaling groups and that service, and it can do predictive autoscaling and all that good stuff. But we actually, for RDS and for DynamoDB and for everything else, we kind of wrapped up the semantics, the common items, into something called application autoscaling. So now when you want to go and autoscale the Aurora instances, that will actually happen through application autoscaling.
Yeah, isn't there some page in the console where you group your
Yeah. And that's
on EC2, right?
Well, no, it's in application autoscaling.
Oh,
it's
okay.
its own service now. So
Okay.
EC2 still has its own autoscaling groups, but you can import EC2 autoscaling groups into application autoscaling, and you can even read metrics, CloudWatch metrics from that to trigger scaling on the database layer or scaling on some other layer. And it wraps it all into one nice little package. And you can build CloudFormation scripts with this. And
I was going to say, because this is a huge topic, right? Like, just say, just scale it, right? Just spin up more or use bigger instances, scale up. Like, that's a gross overgeneralization of, like, what it really means to efficiently scale things. And every single one of these different services, whether you're just running random applications on an EC2 server or databases, will have different optimal pathways to scaling. And so sometimes you need to have entire services dedicated to doing that in an efficient manner.
a whole microservice dedicated just to autoscaling. It's true. And, and it's probably an amalgam. It's a macro service, so there are probably several microservices around that. There's one question that I'm still a little unclear on, which is the storage. That grows automatically.
Correct, and we actually didn't mention that we keep 6 copies of your data. That's actually one of the the biggest claims to fame in Aurora, is that if you look at, so we have 3 availability zones, AZs. We keep 2 copies of your data in each of those AZs, so a total of 6, which, going back to what we started the show with, I mean, would have been crazy, 20, 30 years ago. 6 copies, I mean, 2 is kind of generous.
Yeah.
But now we can keep 6, and it's highly, highly unlikely that all 6 of them will die. We have rules around what happens when 4 out of 6 are alive, 3 out of 6 are alive, which again doesn't really happen in real life. I mean, it's pretty rare. I mean, but we need to plan for them. You always have to plan for them.
As Werner is fond of saying, at scale, everything fails all the time.
Okay.
So I get why we build out that kind of, high availability, ridiculously high availability in some cases.
Correct.
So at scale, things break. You also start to notice different patterns that only you may face. And so we've talked a lot about the value behind it, but I want to highlight sort of and talk about our usage of Aurora internally at Amazon, because we are one of the largest users of Aurora, right? So recently, we finally migrated from another company's database off to Aurora. And this was a really big deal, right? Because for a long time, we recognized that Aurora solved the problems for other customers, but it was a very long transition to be able to use it internally for our fulfillment services. What was that like? Or like, what does Aurora really provide there that we weren't able to get prior to that?
Yeah, so that's been a multi-year process to migrate pretty much all of Amazon to our own database services. Specifically for AFT, Amazon Fulfillment Technology, I think it's what it stands for. This is the group that's running our fulfillment centers, basically these warehouses where you get stuff, in 2 days to your home. So we switched all, there were many, many hundreds of instances, which we switched from another database company, as you called them, and those were switched.
I mean, I'm gonna stop. Like, it's Oracle.
Yeah.
Yes. Let's call a spade a spade.
Like if someone's speaking with derision about a particular database, it's Oracle.
It's very They have a lot of credit as, they've been a very, successful, and, they have good products, and, we can do anything that we need today with our own, database services. We don't, and when we get all kinds of advantages things that you could not do with Oracle in terms of scaling, in terms of cost, in terms of other advantages. So we were able to move the last fulfillment center to Aurora Postgres at the end of March. So there was a tweet from Werner Vogels and others
pushed it out.
About that. So that was a very happy moment, and that was in a long line of other migrations that we did into from Oracle to AWS database and analytics services over the last few years.
And it's not just people that are operating at Amazon scale. There are a number of different customers that I've worked with just based in Los Angeles, where I am, that are excited about not having to enter into these long-term contracts and long support contracts and things like that just to be able to store their data and access their data.
Correct.
So I like the pay-as-you-go model, and you're only paying for what you use. All those things that are typical of the cloud. It's really that realization. And so should we maybe get to questions, or do we have enough time?
I think we can get back to questions really quickly. I just wanted to talk about that process, right? Like, that's a very long process. It was multiple years, as you mentioned. Obviously, not everyone is operating at the same scale as Amazon, so it may not take them multiple years to do a transition.
And by the way, if you break that down into smaller chunks, some of these fulfillment centers were, I think one of them was migrated. It was less than an hour, from what I remember. So your application and your database might be no bigger than one of, like one fulfillment center at Amazon. So maybe I'm not saying everybody can migrate from Oracle to Aurora in an hour, but I'm just saying, it doesn't need to be necessarily very difficult. Yeah. There's certain steps you need to take, for sure.
And I know I'm opening a bit of a can of worms here, but we offer tools internally to be able to help with that, right? Database migration is a common workflow that people need to undergo. What are those tools that we offer? And we don't have to go too deep, because that'll be its own episode later on.
Okay, good.
But what does that look like for someone saying, "Hey, I want to get onto Aurora from another database"?
So two main things that we offer. So in terms of product, the schema conversion tool is a tool that you can download for free, and what it does, it will look at your database schema from almost anything to anything. I mean, they keep adding these new combinations almost, it feels like every morning. So you want to migrate from Oracle to Aurora to DynamoDB. You want to convert from a data warehouse to a relational database to a non-relational. All these different combinations. It makes it much easier. It converts what it can, and then shows you the things that you need to convert manually if there's some line of PL SQL code that it didn't understand or couldn't convert automatically, or stored procedure.
Like that.
Exactly.
And so that's another really cool thing with Aurora is you have like a Lambda function stored procedures.
Correct. We could talk about that.
But we only have 5 minutes left, and this is office hours, right? This is for you guys to ask us questions. So we're going to do some rapid fire questions now. Are you ready? The first question is via email to our database deep dive at Amazon.com, databases deep dive at Amazon.com, from Bojan Gajic. I don't know how to say that last name. I apologize. He asks, what are the differences and what are the best practices for operating Aurora Postgres versus operating traditional Postgres? They want to optimize for read heavy versus kind of write workloads.
Read heavy versus write workloads. So, one of the biggest differences with standard Postgres is what you don't need to do, obviously. So you don't need to do all that management and backups and patching and all of those things. You can definitely, for read heavy workloads, you add read replicas.
And you can have if 21 regions, read replicas is up to 15 of them, right? So 21 times 16 different nodes, and it's like 336 nodes or something.
Correct. Just a caveat that the version that is deployed right now copies to one other region, and we're coming out with the one that copies to all of them pretty soon. So if you want to get started, you can start with copying to one other region, and just wait for the other version to land, which is pretty soon.
But MySQL is multiple regions right now.
Well, what I just described is MySQL. So if you're asking but if we're asking specifically about Postgres and using global database, that's on the roadmap as well.
Okay, gotcha.
So we will do that for Postgres as well.
I have another question from the chat. This one here is from Homero Co. Question is, if they distribute over multiple zones and then also scale EBS over multiple zones, how do they know which EBS server is accessing which Aurora instance in which zone? So we've got a lot of multi-region, multi-zone
does Aurora
going
use
around.
EBS?
It does not. It does not. So Aurora has its own unique storage system. We haven't actually talked about that, but EBS is what we use for other database engines. For the standard MySQL, RDS MySQL engine, we use EBS. For Aura, we built a completely purpose-built storage system, which is log structured. So, and we could talk about that for hours.
It's really
but
cool.
It's really cool. It writes all of your changes as a kind of endless log. It's actually a little bit more like what databases usually do than what storage systems usually do. And moving back to a previous state is a matter of just using previous logs that are still there and just using them instead of the last ones. It's a pretty cool thing. So that's how it works. It allows us to do a whole bunch of interesting things. And not that there's anything wrong with EBS, but just this is a more unique fit for databases.
One is optimized for kind of random access block storage or sequential access block storage, and one is optimized for, databases and any kind of database storage. And
Correct.
If I'm sure your team is probably hiring if people wanted to come work on this.
We are actually. Yeah, if they are. I mean, if you want to work on the storage layer, for example, lots of opportunity. And by the way, these logs, guess how we do global databases? We copy those new logs to the other region. That's exactly what it
and
does.
the pages and all that.
Yeah,
so
exactly.
we have another, Homerow is clarifying he meant Elastic Beanstalk, and I think that was a little bit of confusion. The way you connect to this is through the endpoint. So you get a connection string URI, you go and you connect to that URI, and you say, hey, it doesn't really matter what AZ you're connecting to or from, because that URI is going to be unique to that Aurora cluster. Do we have time for any?
Yeah, we have time for one last question.
more.
We have, I think we can go a little over at one. So last question is from Richard Boyd again. He asks, if Aurora is based on EC2 and related services, does it have to be in a VPC? How does this relate to the fact that it's serverless or has a serverless configuration available?
But do you need to be in a VPC to access it?
So quickly, yes, you need to be in a VPC. I think there's an older way that might still work for some customers, but I think that's kind of getting deprecated. I mean, you can still use it, but it's getting deprecated. So yes, you do want to be in a VPC. In the specific case of serverless, it uses a networking technology whose name I keep forgetting. And that means that either your application is in the same VPC as the database, or you can use the data API that we mentioned earlier and you access your Aura serverless database through HTTP.
Like through Hyperplane?
Not Hyperplane, some other name.
And then Skullcrusher for Life has what I think is a pretty good feature request for your team, which is when spinning up a FastDB clone off of prod, can you run any sort of data masking script on the data or any sort of transform on that snapshot so that you could remove PII data so that customers who wanted to run a developer workload could be masked?
Like the social security numbers.
Yeah.
We've thought about that. We don't have that feature today. You can use third-party masking solutions, with Aura.
I mean, even with Glue, you can crawl the table in as a G.
Correct. If people feel strongly that we should have that as our own feature provided by the Aura RDS team, then let us know. We're definitely open to that kind of input.
Well, Skullcrusher for Life, which is what a weird name, sorry, is very enthusiastic about that. And do we have any other questions from the stream?
Let me just give it a quick look. I think we're good, but obviously...
Dos Dillon is asking if Aurora Postgres instances will be available. So because now Aurora MySQL instances, you can go to like T3 or T2, large, I think is the smallest now, or T2 medium?
T2 medium, I believe.
So
maybe small. I think small for Aurora MySQL. I think small.
Nice.
So you know what? I don't... I'll have to look.
I can look and follow up with you after this, but the question is, when will Postgres be able to run on smaller instance sizes as well?
So Postgres, I will need to check on that. Definitely T3 series. I don't remember if it's available now. We can.
So I'm going to post the email for the questions that we didn't get to today.
Okay.
So it's databasesdeepdive@amazon.com. Any questions that we weren't able to answer on the stream, follow up, and we'll either answer them in the next show or we'll answer them just via email because you have access to all of these amazing experts. A couple things to cover. We will not be on next week because something important is happening.
We're going to be at a conference, a big one.
Yeah. We're going to be in Canada, which is, not that important, but...
Important part is we're not going to be here in the studio, so we're going to be taking a week off. We will be back again in 2 weeks, I believe, with one of our favorite guests, Joe.
Joseph, to talk about DocumentDB.
Yeah, so thank you for all of your questions. Again, we have the email in the chat. We're looking forward to hearing from you. And if we don't hear from you before then, we will see you in 2 weeks on Tuesday for the next episode.
Thank you so much for
Thank
coming.
you so much.
It was a lot of fun.
It's been fun.
We'll have to have you back.
All right.
No worries.
Take it easy, everyone. Have a great day.